And I'm gonna switch my stream to the full screen in case I want to do some annotations. Okay, so we'll get started talking about random. Um, as usual, if you have any questions while I'm going over this, feel free to interrupt me at any time. So let's go back to the schedule. And so we covered loops on Monday. Random and loops are not necessarily associated, like you don't have to use them at the same time. But since we're doing a loop, it's a good time to also add some randomness in. So you can use random at any time. It doesn't have to be part of a loop and vice versa. But using a loop with some random is a good way to kind of create some variations in a composition. So I'm gonna do most of the stuff in P5 today, but I want to show a couple things in the console when we get started. So random is just a function that JavaScript has by default. It's part of the math object. So, excuse me, if I type in math into the console, you'll see it's this whole big object. And it's got a lot of stuff in there that's really useful. And P5 gives us access to a lot of that stuff, just kind of like without having to type math in front of things. So, like for example, we use pi in the past, and you can see pi is actually stored right here. So in pure JavaScript without P5, if I type pi, it's undefined. If I want to get a reference to pi, I have to use math.pi. And so one of the things that P5 does is it just kind of gives us quicker access to certain things that are built into JavaScript. Another example is like that sign function that we saw earlier in that assignment. If I say sign, like in P5, that's undefined. But if I say math.sign and I want to get the sign value of an angle, let's say math.pi, it'll give me that value. So the math object has a whole bunch of different stuff in it that we can use. And one of those things is a function that generates a random number, which is just math.random. And so math.random, anytime you call it, it's going to give you a random number between 0 and 1. So, every time I do this, you can see we get different random numbers. Some of them are close together, some of them are far apart, but they're all pretty random. You can see there's enough digits here that it's pretty unlikely that we'll repeat a exact number within, a lot of runs of this function. But with math.random, it's a little bit limited because it only generates numbers between 0 and 1. So we can do a whole lot with that. Randomness is very useful, but in order to make it useful for different things, we have to convert it to different ranges, kind of like our map function. So if we are trying to randomize, for example, like the size of a tree in a game, 0 to 1 is not that useful. We could, if we don't want all of our trees to be between 0 and let's say 1, unit tall, we might want trees that are between like 50 units and 60 units. So we'd have to do a little bit of math. We would have to say the smallest value for a tree is 50 and the largest value for a tree is 60. So to do that, I'd start with 50 and then I could add a random number and multiply that random number by 10. So that would get me the rest of the way to 60. So I'd have a tree that's 56. I'd have a tree that's, in this case, about 58, 57, 59. So using random, we need to kind of like do a little bit of math around random to make the values more useful. Um, and P5 does a lot of that stuff for us, so we can just use the random function and it'll actually kind of like do different things for us. So we have to move over to P5 for this to work. But I'm just going to start with a few values. I'm just going to log some values in setup just to kind of show some different examples of randomness. Um, so I'm going to go in here and I'm just going to do console.log and random with 5 as my argument. And let's actually go ahead and open up P5 reference and take a look at random as well. So if you're in the P5 reference, you'll find random in the math section. So you can see all the different math functions that P5 makes for us. And then down here, you see random. And there's actually a couple different types of random, but we're just going to cover the main type today. If you're interested in exploring other types of random, Gaussian random is a good one to look at, and then random seed is a way to change the random values that we're getting. So let's take a look at random, and you can see in the examples, there's these lines of random length, and this gives a random word. And so there's a few different ways to use random. You can see there are optional arguments here. There's a min value and a max value, but both are optional. And then you can also give random an array or list of choices. So we'll mostly be working with this top version, but there's another version that we may see later. So actually, let's just look at random by itself. We're going to see that that does the same thing as our math.random function. So if I run this sketch, I'm just logging a random number, and you can see that down here, it gave us this random number, 0.09. And so we can put this in a loop to see a bunch of random numbers. So let's say for let I equal 0, I is less than, let's say 10 random numbers, I plus plus, and then we'll just log random. And we can ignore this drawing for now. Let's just look at these nice random numbers. So all of the 10 random numbers that I've generated are somewhere between 0 and 1. So none of them are above 1, none of them are below 0. So we have 0 0.6, 0 0.4, 0 0.7, 0 0.01, etc. So if we want a bigger range, we can add an argument in here. So let's put in 5 and then run our code again. So now notice that our maximum value is going to be 5, and our minimum value is still 0. So we have 1.7, 0, 3.8, 0.3, 2.8. So these numbers are still random and unpredictable, but now the range of values is different. So when we put in a value here, even though it's in the position of minimum, it actually acts as the maximum. So this documentation is a little confusing, but notice that both the min and max are in brackets. They're both optional. And when we don't have a max value, the min value gets used as a maximum instead. Um, on the other hand, if we do a negative value, now it actually becomes the minimum value again. So if we do a negative value, now you can see we have -2, -1, -0.157, -4. So we change the range from 0 to 5 to -5 up to 0. So when we have one argument, it's always going to be between that number and 0. If we have two arguments, so we can do 5 and 10, now it's going to make a random number in between 5 and 10. So I'll run that again. And so now we can see 6.8, 8.15, 9.7, 6.2, 8.5, etc. So none of these values are over 10, and none of them are below 0.
Professor, is there a reason that it goes like so many decimals? Like,
Um,
is there something wrong with just getting 6 and 7?
Yeah, so that's a good question, and it actually has to do with the way that the random number is generated. There's different mathematical formulas for generating random numbers, and the one that JavaScript uses, it's been a while since I actually read this, but it's basically what it's sort of doing is it's using like sine and functions similar to sine to generate like ridiculously long numbers, and then it's just taking a section of that number and then using it as a fraction. So that's why the numbers are so long. It helps it be more random, essentially. The more numbers you have, the less likely those numbers are to be the same. Like if you were imagining that you wanted to generate a unique password, the easiest way to make a password more secure is to have lots and lots of different numbers or characters in the password, because the more characters you have, the more numbers you have to get right to guess the password. So it's the same thing with random. The bigger the number is, the more likely it is to not be another number. So that's why it's so large. But we can kind of like change it. We can change the value to use, we can use a smaller range. So if we're if we want, like, let's say 3 digits worth of randomness, I could say random to 1000, and then I could just round it. So if I want to get the rounded version of a number, I can take this random and I can wrap it up in a round function, which will round the number for me. And so now I'll get 3 digits worth of randomness. So all of my numbers, again, are random, but they're somewhere between 0 and 1,000. So 700, 317, et cetera, et cetera. So yeah, the original random number is going to be really long, but we can use whatever part of that number we want to for our purposes.
Right. So basically, it's like you're not gonna get 799 twice. You're gonna get 799.1 whatever and 799 point something else.
Exactly. Like if
Okay.
we So if I just did random by itself and I round it, all of these numbers, then it's not going to be very random, right? Because it's either going
It's
to be
gonna be one or
0 or
zero.
1.
Right.
So there's not a lot of options. However, if I, do random of 10 and I round that, now I have some more options. I have, 10 options. So there's still going to be numbers that are repeated, like this number 3 is repeated here, 9 is repeated here. And so it is technically random, right? It's not predictable, but we don't have as many options, so we're not going to have as many possibilities. So it's not quite as random as it would be if we use a larger number. But that's a good question. If you're interested, there probably uh, there might be an explanation.
As to like why they do that,
Um,
because that's my biggest confusion as well. Is like why does it really matter that you can't or that it's so like why would it not be automatically rounded to 2 digits or something or two decimals, whatever that kind of thing, I guess, is. But I guess
uh,
that's something I can look into as well.
yeah, I mean, it probably just has to do, I would guess, um, that it has to do with the algorithm that they chose. I mean, at some
Okay.
point, it's a choice of the
Yeah.
developers who created JavaScript.
Yeah, exactly. I was just wondering if that choice made any sense.
Yeah, I'm sure it has to do with efficiency. So like if some programs might call random like 1,000 times in a frame. And so probably part of it has to do with efficiency. It may be more efficient to generate a floating point number in some cases. But it may also just be, with this one function, since you know exactly how it works, like if it rounded the number based on some input, then we'd have to always keep that input. Whereas a lot of the sort of like low level utility functions in a language will have like one really basic way of working. And then other developers, like the people who made P5, can build on top of that to do things that are more useful, or fit a specific use case. Um, Let me see if there's any. It doesn't say what algorithm it uses. Let's see. What algorithm does JavaScript math random use? Random based on an algorithm called Exer Shift 128 plus. Okay, let's see if it's implemented using a pseudo-random number generator. The upper bound of the period length is 2 to the n. I think it actually it looks like it has to do with just like the internal like the
They
Chrome.
just chose for it to use 128 bits.
Yeah,
It was okay. I guess that makes sense. Or maybe
yeah,
it was just something like we can't see anybody needing more than this.
right. Yeah, and if you did, you could write, you could just write your own. Um,
Right.
so yeah, I don't think we're probably not going to understand this very well, but this is the algorithm that is used to generate random. Uh, let's see, based on z/2z linear operations using multiplication by a suitable constant. It probably uses like the date or something because the date is always changing. Um, but I'm not sure. And yeah, it also has to do with like what is just efficient for the computer to do.
Yeah, that makes sense. All right.
So, anyway, there's a lot of stuff to get
Yeah.
into with that is interesting, but probably a little bit outside the scope of this class. But yeah, so let's continue looking at some random numbers. Let's see. So we've looked at the min, the max, and using the min and max together. And then so we can use random to generate things like colors. Like if I say 0 to 255, I'll get a number between 0 and 255, which I can use as the value for red or blue or green. I could say 0 to width, and then I'll get a random number between 0 and the width of the canvas. Again, I could use as the position. So it's really useful to just create a bunch of random numbers, and then we can, kind of constrain them in various ways to change the way it affects the design on the canvas. So let's keep going and look at how to randomize shape, size, and position and color. So in this example, we're randomizing the color. And so we're just creating a different fill for each one of our faces in our pattern. So let's go back to our pattern and see if we can implement this. I have to get back I'm just going to refresh this. So one thing that we're going to run into here is that we're still using the draw function. And what's going to happen when we're using the draw function and random together is that we're going to be refreshing these random values a lot. So I'm going to use a quick example of this. I'm going to replace the fill red with a fill for a random color inside of this for loop. So I'm going to create a variable for r, variable r equals random between 0 and 255. And for green, variable g is random from 0 to 255. And then variable b, also random 0 to 255. So this will give me just a completely random color, random red, random green, and random blue. And when we run this code, we're going to see an issue, which is that it's constantly refreshing because we're still using the draw function. So that's kind of cool. You might like that effect, but it's also a little bit crazy looking. So for this uh, part of our assignment, let's go ahead and just remove the draw function altogether so we can just generate one version of our pattern. So I'm just going to take out this function draw, and by taking out the bracket that's directly above it, what will happen most likely is that your setup bracket will connect to the end of the draw bracket. And so we can quickly get rid of our draw function just by deleting the function draw and the setup bracket. If you have something else going on in your code, like a mouse press or something like that, you may not be able to do this, in which case you can just delete the setup. I mean, it's kind of going to look like the same thing, but let's delete the setup and then delete the draw. And so our setup will go straight into drawing our sketch. And so this way I can generate a pattern without kind of having it flash all over the place. So that's a little more sane looking, at least for today. We can talk about ways to um, keep those random numbers around in future classes. But for now, let's continue randomizing these colors. So as I mentioned, we are able to control the range here. So right now I'm using any value between 0 and 255 for the red and the green and the blue. So that's good if you just want a completely random color, but if you want a color that fits within a specific color scheme, so for example, these faces used to be red and we had this kind of blue, red, green thing going on. If we want them to be more red than other values, we can do a couple things. We can kind of like blend our colors together. So there's different ways to do this. We can change the minimum value for our random red to 200. And so that means there will always be at least 200 red in our color and somewhere up to 255. So when we run this again, we're going to get more red on the average. You still see other colors because we're still getting a fair amount of green and blue. So if you really want them to be red, we need to reduce the amount of green and blue that are possible. So we could lower the amount of green to like 200. So now green could be 0, but it could be up to 200. And blue could be 0 or up to 200. So now we're getting closer to red. We still have some pinks, some oranges, some yellows. So we may need even less of those values. We could say 100 for green and 100 for blue. So now we're pretty red all over the place. There's some oranges, some purples in there, but for the most part, things are pretty red. So you can kind of play with the amount of randomness that you're putting into different values to give to kind of constrain and have a little bit of control over the randomness, so it's not just completely random. So that's color. Let's look at other things that we can randomize. So we can have random size. So in this case, we have a bunch of different self-portraits and we're randomizing the size value. So let's try to implement that over here. Um, where's my, so here's the circle for my self-portrait. This is the head, and then the eyes are down here. Let's move this over a little bit. Left eye and right eye. So the size is typically 200. So if we change this to a variable, we can say variable s for size equals 200, and then I can put s in here. Or wait, no, I keep doing that. That's the y value. Okay, so then this one is not size, but 20, which is 1/10 of the size. So let's just make another variable for that. So that's our main head size, and then we can have an eye size equals s divided by 10. So I'll put the eye size in for our eyes. Oops. And then we also need the mouth. So the mouth is actually 40, which is 2 times the eye size. So let's say variable mouth size equals eye size times 2. And so I'll put mouth size here. And then so the width and the height of the mouth are different. So I'll do mouth size over 4 for the height. And I'm just going to leave 5 for the corners. And so that will look the same, although I wrote mouse instead of mouth. Okay, so now we can randomize the size and everything else should move along with it. So instead of 200 here, let's replace this with random. And let's say the lowest is 100, the highest is 200. Oops, I must have put in S. Yeah, I put in S for the y value for my head by mistake. But this is actually kind of cool. It's a little bit more interesting than, what I was probably going to do. But let's make it do that on purpose. So instead of size, this was 200. The size was actually 100. I was looking at the wrong coordinate. But anyway, let's put size here. And then so eye size would actually be different, but let's see what it looks like. It's going to look weird. Oh, and the the offset is the same as well, so it doesn't quite work. So the eyes actually should be a little bit bigger, uh, but we could also randomize that. Let's randomize it. That'll be more interesting. So for our eyes, let's do random, but let's do random based on the size of the head. So let's say the biggest eye is going to be half the size of the head, so that would be s over 2. And then the smallest eye will do s over 5. And so that should give us some interesting results. So we have some different sizes of the eyes. So that's kind of cool. I think s over 2 might be too big, so let's do s over 3 as the biggest value. And then they're always the same distance apart. So again, you might think that's cool. You can leave that the way it is, but if that bothers you, we want to change the distance. So let's say I distance, and let's just use the same thing. Oops. So I'm just going to do a different random value for the I distance. And the I distance is this 20 right here. So this is the Y value, and this 20 over here as well. So I distance, I distance. So now we're getting uh, different distances, different sizes. And so you can see now we're getting a lot of variation in these patterns. So you might not want this much variation. You don't have to, I like to add variables to make it really clear everything that I'm doing, but you don't necessarily have to do it this way. You might think it looks better to just have some things the same and some things different. I actually liked it better when I was just accidentally randomizing the Y value. So why don't we go back to that? Uh, but this is just an example of different ways that this could work. So yeah, I kind of liked it when the Y value is random for the head, but not the rest. So let's try that again. So let's say variable Y is random, and let's say between the top of the canvas is like 100, something like that, and the middle of the canvas is height divided by 2. So I'll just stick in Y here. And that looks kind of funny. Now my head is kind of randomly positioned above the uh, eyes and mouth. And I think the size of the head is a little bit too big. So let's bring that down a little bit. Let's say the max size is 150 and the min size is 50. Okay, that's a little bit more reasonable looking. So yeah, we can add randomness, and now we're getting all these variations to the pattern without having to kind of move things around ourselves. So this is another example of when I'm doing design, using programming gives me a lot of different potentials that I wouldn't be able to do just using like Illustrator or Photoshop or something like that. Like obviously I could draw or create these different designs, but now I can just hit the play button over and over again and generate, as many new designs within these various parameters as I would want. Um, okay, let's see if there's other stuff to cover and then uh, any questions. So we randomized the size. We also actually randomized the position a little bit, the Y position. So we can see a simpler version of that here where we're saying Y is random between height over 2 plus 40 and height over 2 minus 40. So it's kind of creating a little band in the middle. So height over 2 is the middle. And so plus 40 would be down here somewhere, and minus 40 would be up there somewhere. So it's not completely random, but we get some randomness with where our pattern shows up. And in here, I think we're randomizing everything. So yeah, we're randomizing in a similar way the color, the size, and the position of each one of our shapes. Um, so let me talk a little bit about the assignment and then um, I'll see if there's any questions. So for this week, uh, we just need to do a variation using loop and random. And since we're using loop and randomness, you should document a few different versions of the pattern. So we can capture a few versions of this. So I'll go over how to do that again. Since we're not using draw in this example, let's actually move this over here. Since we're not using draw, you could just put save in the bottom of your code and save different versions of it. But we can also put the mouse pressed in there so it's not automated. So after we draw, we can say function mouse pressed and just save an image. So let's save pattern.jpg. And so now, even though I'm not using the draw function, this should still work. So if I run my sketch and I click on the canvas, it'll save a copy. And then if I run it again, it'll change the random values. And I can save another copy.
Could you put like setup function in there again? Can you call setup once it's already been called?
Um, no, but well, actually, you probably could, but you wouldn't want to because it would create another canvas. Actually, let's see what happens if I do that. I'm kind of curious. But what you're talking about is actually what we're going to do next week when we do an interactive version of this, which is to put all of this into a different function that we can call. Um,
Okay.
yeah. So yeah, we're going to talk about that next week. But let's see what happens if we call setup again. So if I click here, oh, nothing bad happens. I guess it just replaces the canvas and it does run the function again. So yeah, I guess you could do it that way. I'm just doing a bunch of variations. That's kind of interesting. So I guess it must just detect that there's already a canvas there and it must grab that same canvas.
Hmm.
Uh, I wonder if I give setup arguments, if it'll work. What if I say WH and I'll say W or 800, and this is totally an unnecessary tangent, but I'm just kind of curious to see what happens if it changes the canvas size. So let's set up and try to do a different canvas that's 300 by 600. Oh yeah, it actually does it. Okay, let's do a random. Last one, random 300. This is probably going to do something weird. Random uh, 400. Let's do random 600. Oh yeah, it actually kind of works. That's kind of cool.
That's actually kind of interesting.
Yeah.
I had to step away to answer the doorbell. That basically the X and Y of setup is canvas because that's the first thing that's in it, or why does that change the?
I just put in
Oh, oh,
arguments
I
to see
see.
if it would work.
Okay,
Uh,
yeah, that makes sense.
and I didn't think it would, but it does. So that's good to know. Anyway, so I've got a bunch of variations of my drawing. So when I go over to the Open Lab to post my documentation, just include at least 3 variations of the project so we can see how the randomness is being used. So, once you set it up, it should be easy to generate a bunch of different random ones. And then just include at least 3 of these so we can see kind of the range of possibilities in the pattern. So yeah, that's the assignment for this week is just using loop and random, create several variations of a drawing. You could go back to your self-portrait. You could use like the artwork assignment. You could use a series of windows is kind of like a nice way to do it because you could have like different windows or whatever abstract pattern you're interested in creating for this assignment is fine. Um, so yeah, that's what we're gonna do this week. I'm gonna stop the video and see if there's more questions.